Hello everyone, so for today's video, we will be talking about the normal distribution. So we're going to tackle what is normal distribution, the properties of it, empirical rule, and some examples. So what is normal distribution? Normal distribution, we call this a bell-shaped curve. Carl Friedrich Gauss discovered it, so sometimes people call it Gaussian distribution. It is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. Normal distribution can be found practically everywhere. In nature, in engineering and industrial processes, in social and human sciences. Many everyday data sets follow approximately the normal distribution. Why? Because it is used to illustrate the shape and variability of the data, used to estimate future process performance, and normality is an important assumption when conducting statistical analysis. Like for example, a certain SPC charts and many statistical inference tests require the data to be normally distributed. So now let's talk about the properties of a normal curve. It is a bell shape. The curve is symmetric about its center. Symmetrical means kung anong nasa left side na sukat, ganun din sukat ng nasa right side. The mean, median, and mode coincide at the center. So mean, median, and mode are equal. The tails of the curve flatten out indefinitely along the horizontal axis but never touch it. Pa-close lang ng pa-close sa ating x-axis but hindi ito didikit talaga. The area under the curve is 1. Thus, it represents the probability or proportion or the percentage associated with a specific of measurement of values. Kapag kinuha ang total area ng normal curve, it is equivalent to 1 or the probability 100%. It depends kung ano ang hinihingi. The change of value of the mean shifts the graph of the normal curve to the right or to the left. So, nagbabago ang itsura ng graph depende sa value ng mean. So, kung mataas ang value ng mean, mag-move ito sa right. Pero kung mababa naman ito, sa left side naman ito mag-move. The standard deviation determines the shape of the graph, particularly the height and width of the curve. So, depende sa standard deviation ang shape ng graphs. So, pag malaki ang standard deviation, yung normal curve is short and wide, while pag small naman yung value ng standard deviation, ito ay skinnier and taller graph. Now, let's proceed to empirical rule for the normal distribution. 68.27 of data lies within one standard deviation of the mean. Meaning, yung nakikita nyo dyan sa picture above, yung red lang ang sakop na 68.27%. Next is 95.45% of data lies within two standard deviation of the mean. From purple to another end ng purple, yun lang yung sakop ng 95.45%. Last is 99.73% of data lies within 3 standard deviation of the mean. So, yung buong bell curve, yun na yung sakop na 99.73%. Thus, almost all the data lies within 3 standard deviation. This rule enables us to check for outliers and is very helpful when determining the normality of any distribution. So, ito yung equation for the normal distribution as mathematical function o yung mas kilala na PDF. F of x is equal to 1 over the standard deviation times square root of 2 pi times e raised to negative 1/2 times x minus mean over the standard deviation raised to 2. Note lang na constant yung pi natin, tas yung e na 2.71828. Ito naman yung c-square formula. C is equals to x minus mean times standard deviation over the standard deviation. Now, let's proceed to the C table. Yung C table, it is used to find probabilities associated with the standard normal curve. There are different forms of the C table. First is the cumulative. It gives the proportion of the population that is to the left or below the C-score. Next is yung complementary cumulative. It gives the proportion of the population that is to the right or above the C-score. Last is cumulative from mean. It gives the proportion of the population to the left of the z-score to the mean only. First example, 95% of students at school are between 1.1 meter and 1.7 meter tall. Assuming this data is normally distributed, can you calculate the mean and standard deviation? The mean is halfway between 1.1 meter and 1.7 meter. Mean is equals to 1.1 meter plus 1.7 meter over 2. We will get 1.4 meter. So 95% is 2 standard deviation either side of the mean, a total of 4 standard deviation. So 1 standard deviation is equals to 1.7 meter minus 1.1 meter over 4 is equals to 0.15 meter. Next example is travel time. A survey of daily travel time had this result in minutes. So, andun yung given sa baba. The mean is 38.8 minutes. Para makuha yung 38.8 minutes, at lahat ng given, divide 20. So, i-convert na natin yung values to z-scores. To convert the given 26, first, subtract the mean, 26 minus 38.8 equals to negative 12.8. Then divide the standard deviation over 11.4 is equals to negative 1.12. So, sa 26, ang standard deviation dito is negative 1.12. So, dito makikita niyo yung first three conversions. Katulad lang din kanina, ginamitan lang ng formula para makuha yung standard score or yung z-score. Tapos, makikita niyo din dyan yung graph. So, yan na yung result niya pag na-input na sa bell curve. Next example, if the diameter of a basketball is normally distributed with a mean of 900 and a standard deviation of 0.500, what is the probability that a randomly chosen basketball will have a diameter between 9.500 and 10.500? Here's the solution. Since the standard deviation is 0.500 and the mean is equals to 900, we are evaluating the probability that a randomly chosen ball will have a diameter between 1 and 3 standard deviation above the mean. The graphic below shows the portion of the normal distribution included between 1 and 3 standard deviation. So the percentage of the data spanning the second and third standard deviation is 13.5% plus 2.35%. The result is equals to 15.85%. So the probability that a randomly chosen basketball will have a diameter between 9.5 and 10.5 inches is 15.85%. That's all. Thank you.